This lesson is Geometry, Section 1.2. Before we jump into it, just a little refresher from 1.1. We want to identify what each of these geometric figures is. So our first one is starting and stopping here and here. It doesn't go forever, so we would call that a segment or a line segment. Our second one goes forever in one direction, but doesn't have an arrow at the other end. So this one we would call a ray. And our last one has arrows at both ends, which means it goes forever both directions, so that is a line. So section 1.2 is all about measuring segments. So as a refresher again, we talked about things that we couldn't measure. We couldn't measure a line, we couldn't measure a ray, we couldn't measure a plane. So line segments can be measured, right? Because it starts and stops, so it actually has a physical length to it. Rays and lines cannot because they both go forever in at least one direction. So for measuring a line segment, we can actually measure it with a ruler. Again, I don't know why this picture starts not at 0, but we're going to take it for what it is. So if I were measuring this segment as it was drawn, and we're starting here, and we want to measure it to the nearest 1/10 of a centimeter. So this is 1 centimeter, 2 centimeters, 3 centimeters, and then this stops here, which is 1, 2, 3, 4. So this would be 3.4 centimeters long. Line segments that have the same length are called congruent segments, and congruency is going to be a huge thing in geometry this year. So we can say the length of segment AB is equal to the length of segment CD, or segment AB is congruent to segment CD. So the difference between them is measurements or lengths can be equal because there's actual values to those, but the segments themselves are then called congruent. And we have our little symbol here for congruent, which is different. Notice here we don't have bars above the AB and CD. That's because we're talking about the measurements of those two segments, whereas here we have the bars above them because we're talking about the actual physical segments themselves. So no bar, no extra for the equals. The bars get a little extra. It's equals, but with like a little hat on top, a little congruence swoopy for us. The way we show that segments are congruent are called tick marks. So if I have one segment between these 2 points has 1 tick mark, and between these 2 points it has 2 tick marks, that means these are not congruent to each other because the tick marks don't match. But in the second picture, between these 2 points I had 3, and between these 2 points I had 3, that means they are congruent. So it doesn't matter how many tick marks you're using, as soon as you have a set that matches, those segments are congruent. So what we're going to do in this, we're going to take these points, plot point J, K, L, and M, and we're going to determine if segment JK is congruent to segment LM, which means we're going to find their measures and compare them. So if you recall, when we're plotting points, the first number is how we move left and right, and the second number is how we move up and down. So the point -3, 4 means I would go left 3, and then +4 is up 4. So we would put a point at -3, 4 and call it J. We're going to do the same thing for K. So 2 goes to the right 2 and then up 4. So that's segment JK. And what's really nice is when we have a segment drawn horizontally or vertically, we're treating the coordinate plane as a ruler. We can count the number of spaces that it takes up, and that's how long it is. So this JK is 5 boxes long. Now I'm going to graph L and M. So L is at 1, 3, so to the right 1 up 3. And then M is to the right 1 down 2. So between these, I can count 1, 2, 3, 4, 5 again. So we can determine that JK is congruent to LM, right? They both measured 5. JK was equal to LM, which means the segments are congruent. So we're going to try the check-in. Pause the video so you can try it before you see your answer. All right, so when we plotted AB, we got 5 for that length. When we plotted CD, we got 4 for that length. So since AB is not equal to CD, segment AB is not congruent to segment CD. The next thing we're going to talk about is called the segment addition postulate. And this is something else that's actually pretty big in geometry. So the segment addition postulate says that if I have a segment, AC, and B is between A and C, then I could say the length of AB plus the length of BC is equal to the entire length of AC. So it's saying the sum of the two smaller pieces equals the whole thing, right? So they made a little equation here, AB plus BC equals AC. So if we're stuck, we could always make one of these equations. So if they want us to find DF, right, this is DE plus EF equals DF. So if you were stuck, you can write this out. And DE is really 23. EF is really 35, which means 23 plus 35 is DF. So 58 equals DF. And I could do the same thing now for GH. I could say FG plus GH equals FH. And I know that FG is 21. I don't know GH. And see these bars here? They go from one end to the other. That means everything between F and H is 36. So FH is 36. So this is an equation, right? I want to get GH by itself. So I can minus 21 and minus 21. Come on, go away. So 36 minus 21, we get GH equals 15. If you recognize right away that, oh, DF is going to be those together, just add them. You don't have to make the equation, right? Same thing here. If you know we're going to take 36 minus 21, you can go ahead and do that. But you could also make the equation, plug everything in, and solve. So why don't you try the two check-ins, check-in number 1 and check-in number 2. Again, pause it so you could check your answers before we go on. All right, for check-in 1, if I add together 23 and 50, I get 73. For check-in 2, if I do 144 minus 37, I get 107. The next examples are probably the trickiest ones we'll do today. So if EG, if they're telling us the whole thing equals 71, we want to find the value of x. So now there's two different x's in the problem, and we know the whole thing equals 71. So if I go back to my equation, and I know that EF plus FG equals EG, right? Smaller plus smaller equals whole. Instead of EF, I'm going to write 8x minus 17. And then I have the plus. And now instead of FG, I'm going to write 5x minus 3. And then instead of EG, I have the whole thing of 71. So for this equation, I notice that both of my x's are on the same side of the equal sign. So we're not going to be minusing underneath. We're going to combine like terms. So if I'm combining an 8x and a positive 5x together, that's a 13x. And if I were going to combine the negative 17 and the negative 3, right, not doing minus or plus underneath them, just combining them, that's minus 20. So now our equation's a little simpler looking. All right, we're always going to take care of the number before take care of the variable. There's just one variable, so I'm going to add 20 to both sides. Right, what we do to one, we do to both. And now 71 plus 20 is 91. Now to get x alone, it's being multiplied by 13, so the opposite of multiplication is division. So 91 divided by 13, x is 7. Okay. Looking at example 2, very much the same, except they're telling us TV, the whole thing, is 14x minus 8. So still making an equation where TU plus UV equals TV. We're going to have 9x plus 2 plus 5 equals 14x minus 8. So before I go any further, I'm going to combine what I can. Right, on the same side of the equal sign, we have a plus 2 and a plus 5, so that's really a 9x plus 7. And now we have variables on both sides, so I'm going to try to take care of my variables first. I'm going to move my 9x over because that was the smaller of the two. So that means I'm going to minus 9x and minus 9x. If that's not the way you did it, that's fine, but this is the way I'm going to do it. So now these are gone. So we have 7 equals 14 minus 9 is 5x, and then we still have minus 8. Now to get rid of this 8, we're going to do plus 8 on both sides. So we're going to have 15 equals 5x. And then the last thing we're going to do is divide both sides. We want to get rid of the 5 here, so divide by 5, and x equals 3. All right, you're going to again try the 2 check-ins, pause it, and then play when you're ready to see the answers. All right, for check-in number 1, we add together 6x plus 1 plus x plus 7 and set it equal to 36. We get a final answer of x equals 4. And for check-in 2, we do 19 plus 4x minus 20 equals 6x minus 35. And we get an answer of x equals 17. All right, just some examples left. There's 2 here and 1 more. It's a little tiny to see on the screen here, but they're showing us that these 3 cities, Lubbock, Tulsa, and St. Louis, all lie in one single straight line. So we want to find the distance from Tulsa to St. Louis. They give us the entire distance is 738, and the distance from Lubbock to Tulsa is 377. So this is just finding this piece here, knowing the whole thing was 738, and this piece was 377. So what we can do is 738 minus 377. So that gives us 361 miles. All right, oh, this is actually a you try. So you're going to try this one. I'll make these numbers a little bigger for you. We know that this value here is 158 between Sacramento and Fresno, and between Fresno and San Bernardino is 230. We want to know the total distance from start to end. So pause it and you can check your answer. All right, for this one, we would add together the 158 and the 230, and we get a total of 388 miles. The last problem doesn't give us a picture. So they tell us that point B is between A and C on segment AC. So right away, they give me this information. I'm drawing this picture. So we have segment AC, and point B is between A and C. Doesn't matter where, just somewhere between them. They tell us that AC, the whole thing, is 95. AB, so A to B, is 15x minus 10. And B to C is 5x plus 5. So we're going to make our equation. We know that AB plus BC equals AC, which means 15x minus 10 plus 5x plus 5 equals 95. And again, I have things on the same side. I have a 15x and a 5x. I have a negative 10 and a positive 5. So 15x and positive 5x is 20x when they get combined, and negative 10 and positive 5 is negative 5 when they get combined. Now I could start working from one side to the other. To get rid of this minus 5, we can plus 5. So that 20x equals 100. And I can divide by 20. And we get a final answer of x equals 5. But that's not all they wanted. It said using the information provided, draw a picture, which we did, and find the values of x, AB, and BC. So if I want to find AB was 15x minus 10, and we just found out x is 5. So that's 15 times 5 minus 10. So that's 75 minus 10, which is 65. And then for BC, it was 5x plus 5. So now that's 5 times 5 plus 5, 25 plus 5 is 30. And let's just double check this. We know together AC had to be 95. 65 plus 30 is in fact 95. So we are correct. And that is section 1.2.